the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is another in a series on row reduction and echelon forms in linear algebra. We need to take a moment to talk about a very, very important piece of the echelon form, or basically of matrices in general, when you're trying to row reduce. And that piece is called the pivot and the pivot position. And there's some specific language that we have to be very careful of here, so I'm dedicating a single video just to this topic. Let's talk about the definition of the pivot position, the pivot, and the pivot column. So a pivot position in a matrix A is a location in that matrix that corresponds to a leading one once you get down to the reduced echelon form of that matrix. So essentially you do not know, this is kind of a big heads up. If I hand you a matrix, or if you're handed a matrix that is not already in row echelon form or reduced row echelon form, it's hard to know what the pivot positions are. It's in fact pretty challenging. In most cases, almost impossible. You have to actually work it down to where you get almost to reduced row echelon form to be able to tell what are those pivot positions. And remember, the pivot position corresponds to a leading one once you get it down to the reduced row echelon form. Continuing with the definition here, the value of the entry in the pivot position is called the pivot. And this is going to be, in my opinion, a very challenging piece to talk about. It's not like it's terribly difficult to talk about. It's just that the value of the pivot, which is in the pivot position, just depends on what you did when you were row reducing the matrix. So that's going to be something we'll talk about when we go into an example. And finally, the pivot column is the column of your matrix that contains the pivot positions. So ideally, you're handed some matrix A, and you decide to do some row reduction on it to get it down at least near enough to reduced row echelon form. Specifically, you're just going to go down to row echelon form. So you do some type of manipulations. And you get it down to a row echelon form like this. The asterisks are just scalars. The black boxes there are non-zero numbers. And then finally you have the zeros below those. So this is a row echelon form. Mainly because, again, any zero rows, which there are none, are placed at the bottom of this matrix. The leading terms are staggered going from left to right. And finally, any values below a leading entry are going to be zero. So that satisfies all the conditions to be in row echelon form. Getting to this moment here, these positions that we have, this position right here, this position right here, and this position right here, it'd be nice to be able to refer to those positions. And so we refer to those positions as the pivot positions. We refer to the columns that have those pivot positions as the pivot columns. And finally, the values of those entries in the pivot positions, those are called the pivots. And it's hard for me to kind of say that, but I'll just write it down below. There we go. So 3 little pieces of language there. You have a reference to the placement of a pivot. It's called the pivot position. You have a reference to the column that a pivot is in. It's called the pivot column. And you have a reference to the value of the number in the pivot position, which is called the pivot. Now, just to let you know, we happen to have already stated that a row echelon form of a matrix is not unique. There's an infinite number of row echelon forms for the matrix A. And you may have gotten down to where these values, let's just pretend, are 3, -2, and 8. But I might have gotten down to where I get a 13, a -2, and an 8. Let's just pretend. So the pivots are not unique. The pivot positions are, but the pivots themselves are really not unique because there's not a unique row echelon matrix for that given matrix A. So let's see this in an example. So here we are in the example, row reduced to echelon form, identifying the pivots and pivot columns in the original matrix and the final matrix. Notice I didn't say anything here about the pivot positions. It's because that's kind of a weird piece in this, so we don't really have to worry about that. Although I am going to identify the pivot positions in this problem, but only at the end. Not a big deal. All right, so row reduce, that's the very first instruction here. In order to row reduce, we just have to decide what we're going to choose as our pivot. See how I already used that word, right? So we're going to choose a pivot for this matrix, and I'll call this matrix A. And I'm going to use blue to highlight where my pivot is. There we go. That's the pivot I'm going to choose for this first column and first row. I know that's going to be a pivot because it'll never turn into 0, and I can use it to kill off all the values beneath it. So let's go ahead and see that in action. I'm going to go ahead and take -4 row 1, add that to row 2. That'll become my new row 2. And along the same lines, I'll take -6 times row 1, add it to row 3, and that will become my new row 3. There we have it. That is one step in the row reduction process, and we're almost very close to getting to row echelon form. It's not there yet, but very close. And remember, just based upon our previous work here, we want to get to row echelon form, and that just means that we need to get this guy to be something. It doesn't have to be 1, and we use it to kill off everything below, so we've done that. Our next goal is to take the next supposed pivot and use that to kill everything below. Now this is an interesting case in that the pivot that we have here, while it can be used to kill the value below as written, and I am going to do that, it's more logical in this case, I think, to just divide that second row by -3. But I'm not going to do it here. The reason why I'm not going to do is I just want to showcase that you do not have to get your leading entry to be 1 in this process. It's okay for your leading entry to be a -3 like we have here. So I'll go ahead and just highlight that. That will be my pivot. And I will take -5/3 times row 2. I'll add that to row 3 to become the new row 3. Now in this case, it actually ends up that the mathematics works nicely still, so it's not that big of a deal to have multiply by -5/3. A lot of people dislike multiplying by fractions. I'm kind of with you on that. But in this case, like I said, it works out nice. And you can see actually that doing that move kills off the actual entire row. That third row is completely gone. So we have this right here and this right here. Those are our pivots. And remember, the columns that contain those pivots would be called the pivot columns. I'm just highlighting that there so that you know we're using that language. So the pivots I've identified in blue, and the pivot columns I've highlighted in yellow there. It's the first and second column. By the way, when you do a problem like this, if there were 30 students in a room and they were all working on this problem to row reduce, whatever, you know, somebody, your neighbor might have decided, you know what I'm going to do? I'm going to take this row and I'm going to divide it by -3 first. So their pivot in this spot, they will have divided by -3. Their pivot would have been a 1. And that's okay. The answers for the pivots, well, that's an infinite set. That is, there are an infinite number of values for these pivots. Their positions will be the same. The pivot position will always be the same within all the matrices, and the pivot columns will be the same. But the pivot values, basically the pivots themselves, there's an infinite number of possibilities. People could have, for example, multiplied that very first row by 10. And so somebody could say, well, you know what? My pivot there was a 10. That's perfectly fine. There's nothing wrong with that. What's very important though, is that you know the pivot column. Those are going to come into play and be very important as you move forward in linear algebra. All right. While this is a very short video, I just thought it was important to do here. So there we have it. I hope that this was informative for you, and I hope to see you in a future video. Have a wonderful day.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook over obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close, don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry. Don't